Okay. One, good morning, ma'am. This is Nayan, Khemka, and Dolly Agarwala presenting to you need of distributed computing for big data for our parallel distributed computing digital assignment 1. When we talk about big data refers to the data sets that are too large or complex to be dealt with by traditional data processing application software. Data with many fields offer great statistical power, while data with higher complexity may lead to a higher false discovery rate. Big data analysis challenges include capturing data, data storage, data analysis, search, sharing, transfer, visualization, querying, updating, information privacy, and data source. In this presentation, we will discuss the basics of big data, and further, we'll see the need for distributed computing for big data.
Big data refers to more diverse data that arrives in higher amounts and moves faster. The three V's, volume, variety, and velocity, is another name for this. Big data refers to larger, more complicated data sets, particularly those derived from new sources. Because these data sets are so large, typical data processing techniques can't handle them. However, these vast amounts of data can be leveraged to solve business challenges you previously can't solve. Although businesses have been gathering massive amounts of data for decades, the term big data only became popular in the early to mid 2000s. Corporations acknowledge the vast amount of daily data and the need to utilize it successfully.
In computer science, distributed computing studies distributed systems. In a distributed system, the components are spread across multiple network computers and communicate and coordinate their actions by transferring messages from one system to the next. The components interact with one another so that they can reach a common purpose. Maintaining component concurrency, overcoming the lack of global clock, and controlling the independent failure of parts are three crucial issues of distributed systems. When one system's component fails, the system does not fail. Peer-to-peer applications, SOA-based systems, and massively multiplayer online games are all examples of distributed systems. The use of distributed systems to address computational issues is frequently referred to as distributed computing. A problem is divided into numerous jobs in distributed computing, each of which is solved by one or more computers that communicate with one another via message passing.
Need for distributed computing for big data. Not every situation necessitates the use of distributed computing. Complicated processing can be done remotely using a specialist service if there isn't a significant time limitation. IT moves data to an external service or entity with plenty of free resources for processing when corporations want to undertake extensive data analysis. The data management industry, which was transformed by robust hardware and software innovations, first demand and innovative innovation boosted the power of hardware by lowering its prices. The new software was developed to use this hardware by automating activities such as load balancing and optimization over a large cluster of nodes. Built-in rules in the software recognized that certain workloads demanded a specific level of performance. Using the virtualization technology, software regarded all nodes as one giant pool of processing, storage, and networking assets. It shifted processes to another node without interruption if one failed. It wasn't that firms didn't want to wait for the results they acquired. It was simply not financially feasible to purchase enough computing power to meet these new demands. Because of the cost, many businesses would merely acquire a subset of data rather than trying to gather all of it. Analysts wanted all of the data, but they had to make do with snapshots to capture the appropriate data at the right time.
Distributed computing allows information to be shared among multiple peoples or systems. Distributed computing allows one's machine's application to tap into the processing power, memory, or storage of another. Although distributed computing may improve the performance of a standalone application, this is rarely the case. Some applications, such as word processing, may not benefit from distribution. In many circumstances, a specific problem may need distribution. Distribution is a natural fit for a corporation that wants to collect data across multiple locations. In other events, distribution can help improve performance of availability.
How does distributed data processing work? In a distributed data processing system, a massive amount of data flows through several different sources into the system. This process of data flow is known as data ingestion. Once the data streams in, there are different layers in the system architecture which break down the entire processing into several different parts. Data collection and preparation layer. This layer takes care of collecting data from different external sources and preparing it to be processed by the system. When the data streams in, it has no standard structure. It is raw, unstructured, or semi structured in nature. It may be a blob of text, audio, video, image format, tax return forms, insurance forms, medical bills, etc. The task of the data preparation layer is to convert the data in a consistent standard format, also to classify it as per the business logic to be processed by the system. The layer is intelligent enough to achieve all this without any sort of human intervention. Data security layer. Moving data is vulnerable to security breaches. The role of the data security layer is to ensure that the data transit is secure by watching over it throughout, applying security protocols, encryption, and stuff.
Data storage layer. Once the data streams in it has to be persisted, there are different approaches to do this. If the analytics is to run on streaming data in real time, in memory distributed caches are used to store and manage data. On the contrary, if the data is being processed in a traditional way, like batch processing, distributed databases built for handling big data are used to store the stuff. Data processing layer. This is a layer which contains the logic, which is the real deal. It is responsible for processing the data. The layer runs the business logic on the data to extract meaningful information from it. Machine learning, predictive, descriptive, decision modeling are primarily used for this. Data visualization layer. All the information extracted is sent to the data visualization layer, which typically contains browser-based dashboards, which display the information in the form of graphs, charts, and infographics, etc. Kibana is one good example of a data visualization tool pretty popular in the industry.
What are the types of distributed data processing? There are primarily two types of it: batch processing and real-time streaming data processing. Batch processing. It is a traditional data processing technique where chunks of data are streamed in batches and processed. The processing is either scheduled for a certain time of a day or happens in regular intervals or is random but not real time.
When we talk about the real-time streaming data processing, the data is processed in real time as it streams in. Analytics is run on the data to get insights from it. A good use case of this is getting insights from sports data. As the data goes on, the data ingested from social media and other sources is analyzed in real time to figure the viewers' sentiments, players' stats, predictions, etc. Now let's talk about the technologies involved in both the data processing types.
The first one is MapReduce Apache Hadoop. Mapache is a programming module written for managing distributed data processing across several different machines in a cluster, distributing tasks to several machines, running work in parallel, managing all the communication and data transfer within different parts of the system. The map part of the programming model involves sorting the data based on a parameter, and the reduce part involves summarizing the sorted data. The most popular open source implementation of the MapReduce programming model is Apache Hadoop. The framework is used by all big guns in the industry to manage massive amounts of data in the system. It is used by Twitter for analytics. It is used by Facebook storing big data. Apache Spark. Apache Spark is an open source cluster computing framework. It provides high performance for both batch and real time in stream processing. It can work with diverse data sources and facilitates parallel execution of work in a cluster. Spark has a cluster manager and distributed data storage. The cluster manager facilitates communication between different nodes running together in a cluster, whereas the distributed storage facilitates storage of big data. Spark seamlessly integrates with distributed data stores like Cassandra, HDFS, MapReduce, File System, Amazon S3, etc.
Apache Storm is a distributed stream processing framework. In the industry, it is primarily used for processing massive amounts of streaming data. It has several different use cases such as real-time analytics, machine learning, distributed remote procedure calls, etc. And the last one that we're going to talk about is Apache Kafka, which is an open source distributed stream processing and messaging platform. It's written using Java and Scala and was developed by LinkedIn. The storage layer of Kafka involves a distributed scalable pub or sub message queue. It helps read and write streams of data like a messaging system. Kafka is used in the industry to develop real time features such as notification platforms, managing streams of massive amounts of data, monitoring website activity, and metrics, messaging, log aggregation. Hadoop is preferred for batch processing of data, whereas Spark, Kafka, and Storm are preferred for processing real time streaming data.
Change in the economics of computing. A lot has changed in the interim. The cost of purchasing computational and storage resources has dropped considerably. Commodity servers that could be clustered and plates networked in a rack revolutionized the economic of computing thanks to virtualization. This shift corresponded with advancements in software automation technologies that vastly improved the system's management. Using distributed computing and parallel processing techniques to cut latency drastically revolutionized the scene. Low latency can only be achieved in some applications, such as high frequency trading, by physically placing servers in a single area.
Big data demands needs solutions. The rise of the internet as a platform for everything from commerce to medical shifted the demand for a new generation of data management software. Engine and internet firms like Google, Yahoo, Amazon.com developed their business models in the late 1990s by using low cost processing and storage technology. Following that, these businesses need a new generation of software solutions to help them monetize the massive amounts of data they were collecting from clients. These businesses couldn't wait for analytic processing results. They needed to be able to process and evaluate this information in real time.
With this, we have come to the conclusion of our presentation. Big data volume, velocity, and veracity characteristics are both advantages and disadvantages during handling large amount of data. It is really difficult to process, store, and analyze data using traditional approaches as such. To process data in very small span of time, we require a modified and new technology which can extract those values from the data which are obsolete with time. The distributed computing frameworks come into the picture when it is not possible to analyze huge volume of data in short time frame by a single system. Distributed computing is the technology which can handle such type of situations because this technology is foundational technology for cluster computing and cloud computing. Distributed computing compute large data sets dividing into the small pieces across nodes. Therefore, number of nodes are connected to communication network and work as a single computing environment and compute parallel to solve a specific problem. So with this, we would like to end our presentation. Thank you, ma'am, for giving us this opportunity to learn. Thank you.
Thank you, ma'am.